say football is a game of inches. In abrasive blasting, it's a game of millimeters. And an increase of 1.58 millimeters result in millions of dollars each year in wasted profit. Nearly every single industrial blasting contractor is losing tens of thousands in this millimeter game. Let me explain. At the heart of every blasting operation is the nozzle's orifice, a precision-engineered opening that controls the velocity, pressure, and efficiency of the entire system. This tiny but powerful component is designed to channel air-fed abrasive at maximum speed. But here's the catch. Even the slightest expansion of the orifice, by mere millimeters, can cripple performance. As the nozzle wears, air velocity drops, abrasive flow skyrockets, and efficiency plummets. And the worst part? This profit-draining problem is happening on nearly every job site, often without anyone noticing. If you're serious about maximizing efficiency and keeping more money in your pocket, stick with us. A few minutes of your time will save you thousands. To understand how such a small expansion in the nozzle's orifice can literally waste tens of thousands of dollars, we first need to establish what contractors think is happening and then contrast it to what is really happening. Since this will include example budgets, we'll include a download link for you to double-check our math. So let's start with labor costs. Here's a generic scenario to help us establish some baseline costs. Let's pretend we have a significant project requiring 90,000 square feet of surface prep. Perhaps a tank or 3 or 5 small tanks. To accomplish this, we'll use a crew of 4 blasters, 1 pot tender, and a site supervisor. Of course, compensation varies due to locality, but for example's sake, let's say the blasters and pot tender each cost the contractor $75 per hour, while the site supervisor costs the contractor $90 an hour in wages, insurance, payroll tax, etc. The crew will work 8 hours per day, 5 days per week, resulting in an anticipated labor cost of $18,600 per week. Now, in exchange for that investment, the contractor expects the following: minimum of 500 feet of surface blasted per day, 5 hours of actual nozzle time, accounting for 60% of the 8-hour workday, resulting in 2,000 square feet per day. Next, let's establish very basic equipment and fuel costs. To simplify matters, let's pretend the only equipment expense for the contractor is a 1600 CFM compressor and the fuel required to run it. Compressor rental, $3,400 per week. Fuel to keep the compressor full bore for the 5 hours of nozzle time. It'll require approximately $494 per day. Together, compressor and fuel will run $46,008 over 9 weeks. And finally, let's establish expected abrasive and disposal costs. The chosen abrasive will affect both costs and disposal fees. To account for various locations across the U.S., we'll establish an average delivered cost per pound of 15 cents. Therefore, to clean 2,000 square feet each day, we'll need $2,400 per day or $12,000 per week. We'll average the cost of disposal per ton at $50. So weekly disposal costs would be $2,000. So here is what a typical contractor would expect to happen. Total weekly costs are expected to be $38,468. So that's what's expected to happen. But what happens to those numbers when the nozzle wears out 1/8 of an inch? The first consequence is significant pressure drop, which signals the start of your theft. Understanding the relationship between the orifice size, CFM airflow, pressure, and efficiency is key to understanding the invisible thief stealing your profits. For industrial sandblasting, 100% efficiency occurs at 100 psi nozzle pressure, regardless of orifice size. At this pressure, the velocity of the abrasive exiting the orifice is roughly 420 miles per hour. This velocity, along with qualifying characteristics of the abrasive, cleans the steel at 100% efficiency. In our established example, a 1600 compressor can only distribute 400 CFM per blaster to create this pressure. And from that 400, about 30 CFM will be needed to operate the air dryer, the breathing air filter, and any climate control tubes, theoretically leaving roughly 370 cubic feet per minute for blasting pressure. Now, looking at this matrix and focusing on 100% efficiency capacity, we can see that a number 7 nozzle orifice is the maximum size the 4 blasters can use. A number 8 nozzle would require 407 CFM per nozzle, which is beyond the compressor's output. And if 370 CFM were the true airflow available for each blaster, it would appear they could actually achieve up to 130% efficiency by getting up to 120 PSI at the nozzle. And so it's most likely that 100 to 110 PSI will be achievable. And let us assume that 100% efficiency is what is driving the performance number of 10,000 square feet per week. But when the nozzle orifice increases, which is a natural process of running high-velocity abrasive through it, that has a direct effect on the amount of CFM needed to facilitate the pressure. In this example, going from a number 7 nozzle to a number 8 nozzle now allows the available CFM to only deliver 80 PSI, which decreases efficiency from 100% to 74%, a drop of 26%. You're only getting 7,400 square feet, which means your timelines, labor, equipment, abrasive, and disposal costs must increase. So let's extrapolate that. Our timeline goes from 9 weeks to 12 weeks and will yield the following increases. And all of this occurs because your team regularly fails to replace a $300 to $500 blast nozzle. If you want a guaranteed way to fix your blast orifice problem, here's Amanda to show you how.
Hi, I'm Amanda Vanderpool with BlastOne, the manager of our strategic accounts here. I've been with the company for almost 10 years. In those 10 years, I've been able to go to multiple job sites and meet with multiple clients to understand what they do on a daily basis and how BlastOne can help improve the efficiency and the performance on each of their jobs. Just a few months ago, I was leading a session, and when I asked the question to the larger group how often they replace their blast nozzles, every answer was different. And some even said that they don't replace them and they leave it up to the blaster to not only purchase, but let them know when it's time to be replaced. In my mind, you couldn't be costing yourself more money by making that mistake. Recently, we've been able to make a significant improvement to what's commonly used on job sites called the nozzle analyzer gauge. Normally, when you use that gauge, you have to remove the nozzle from the nozzle holder and the blast hose, and then check it from the back side of the nozzle. Oftentimes, that can become cumbersome on a job site. So what we've done is come up with go, no-go analyzer sticks. The benefit of these sticks allows you to check the size of your nozzle without ever having to take the nozzle off of the hose. These sticks are clearly marked with the size that you need to use to check. There's a nice chart attached to them that tells you what CFM is required for peak performance and efficiency on your job site, correlating to the size of your compressor. I'm going to show you how simple it is to make sure that the nozzle on your job site is properly sized and allowing you to perform the most efficiently and save your bottom dollar. Thank you for spending time to watch this video today. And if you're interested in any of these go, no-go nozzle sticks, you can find them on our website at www.blastone.com.